Okay, we are in section 14.7 where we get to apply double angle and half angle formulas. If you look at our notes that we have presented us here in green, these are the formulas for both the double angle and half angle formulas. Now, this is kind of a continuation of what we did in 14.6, where we used sum and difference formulas, which the reason why we use the sum and difference formulas is to help us find the exact value of certain angles or radians, which we could use our special ratios from our handouts in beginning of chapter 13. So if we look at the sine, cosine, and tangent of 2a, we identify that we have formulas that we can implement to help us solve it. A is an angle it's either an angle that is part of the special ratios, or it leads us to a reference angle of one of those special ratio angles, and then we can solve it from there. Same thing goes for sine, cosine, and tangent of a over 2. So if your initial angle is smaller than the angle that you're trying to find, then you'd use the half angle. If the the initial angle is larger than the angle you're trying to find, you're going to use the double angle. So if we look at our examples here, I want you to evaluate the trig expression using either double angle or half angle formulas. The first one is the tangent of 3 pi over 8. So if we find 3 pi over 8, I'm just going to convert this to degrees. So this is the tangent of 67.5. That's what 3 pi over 8 is going to give us. Just using 67.5 is not going to give us a clean answer. You're going to get an approximation, but we want to find the exact value of the tangent of 67.5. So what I'm going to do is I realize that if I multiply that by 2, I get 135. So I can rewrite this as the tangent of 135 divided by 2. This and this mean the exact same thing. But from here, I can use the half angle formula to help me solve it. So now I can just go to uh, tan a over 2. A in this case is going to be 135, and I can use either tangent formula to help me solve it. I'm going to use the first one. So it's going to be tan of 135 over 2 equals 1 minus the cosine of 135 divided by the sine of 135. Now, 135 isn't one of our special ratio angles, but the reference angle to 135 is 45, because if you were to say, let's graph this here, this right here is 135 degrees, but this reference angle here is 45. So I can find the cosine of 45 degrees from our worksheet, and so I can say, all right, so it's going to be 1 minus, well, cosine of 45 is the square root of 2 over 2. But since it's a reference angle, we must then go to our chart and say, okay, in quadrant 2, cosine is negative. So that means it's going to be a negative square root of 2 over 2. Since I got negative negative, so this becomes divided by the sine of 135. Well, the sine of 135, I could use the reference angle of 45. So finding the sine of 45 degrees is going to give me square root of 2 over 2. And in quadrant 2, sine is positive, so I can leave that as is. So now I have 1 plus the square root of 2 over 2 all over the square root of 2 over 2. So now from here I get to simplify. So I'm going to break this up into two fractions. So I'm going to say 1 divided by the square root of 2 over 2 plus the square root of 2 over 2 over the square root of 2 over 2. Excuse me. Looking at this second one here, square root of 2 over 2 divided by square root of 2 over 2 is going to give me 1. So now I'm just going to write this as 1 over square root of 2 over 2 plus 1. Now that I look at the first fraction, I can say, all right, since I'm dividing it by another fraction, I can multiply it by its reciprocal. So I can say that this is, so if I just multiplied this one here as a sidebar, I would say 1 divided by, or actually 1 multiplied it by its reciprocal, which would be 2 over the square root of 2. Multiply this across, and now I'm going to say it is 2 over the square root of 2. But I can't have a radical in here, so I'm going to multiply both the top and the bottom by the square root of 2. So this is going to end up equaling 2 times the square root of 2 divided by 2 plus 1. And then these cancel, so then the last thing is going to be the square root of 2 plus 1. Okay? So that's the exact value for the tangent of 3 pi over 8. If you're looking at the sine of 15 degrees, again, that one isn't a special ratio triangle, but if I go the sine of 30 divided by 2, then I can implement 30 as A, and I can use that as, those are one of my special ratio triangles. So, look at sine. I can say, if you look up here for sine and cosine, it has the plus or minus. That only depends on which quadrant it's in. So that means you get to use your sheet, your special ratio sheet, to see if sine is positive or negative depending where that angle is. Here, if you look here, 15 degrees is right here. It's in quadrant 1. Sine is positive in quadrant 1, so I leave it as positive. So here this is going to equal the square root of 1 minus the cosine of 30 degrees all over 2. Now, here, the cosine of 30 degrees is the square root of 3 over 2. So I'm just going to write this in. 1 minus the square root of 3 over 2 all over 2. So now I get to simplify. So since my radical, my 2 is in the radical, I'm going to multiply both the top and the bottom by the square root of 2. So the bottom is just going to be 2, and then the top is going to be the square root of 2 minus the square root of 3 when you simplify it out. Okay? The next thing here on my directions, they want us to find the cosine of 2a, and they also want us to find the cosine of a over 2. What they give us is tan a equals 3/4, and a is in between pi and 3 pi over 2. So first step that I would do is let's make a graph. So I got my graph here, and they tell us that it's going to be the angle of A is in between pi and 3 pi over 2. So that one, that means it's telling me it's going to be in quadrant 3. So I'm going to make a triangle in quadrant 3. So A is right here. They're telling us the tangent of A is 3/4. So opposite, but this is going to be -3. And then we have -4 as my adjacent angle. So we have Opposite over adjacent, negative 3 divided by negative 4, excuse me, is a positive 3 over 4. So being able to use the double angle and half angle cosine, I still need to find what sine A and cosine A are. So first thing I need to do is I need to find what my hypotenuse is. My hypotenuse, I can use Pythagorean theorem, so a squared plus b squared, so it's going to be 9 plus 16 equals 25. The square root of 25 is 5. So I can say that the sine of a in this case is going to be a negative 3 over 5, and the cosine of a is going to equal the negative 4 over 5. So those are going to help me solve these two values. So if I go to number 1, if you look up in the chart, you have 3 different ways you can write the cosine of 2a. Any one of them will work. The reason why there's so many of them is to help you when it comes to trig verification, which we're not going to do. You're not going to see until probably when you see trig as a class or pre-calc, something of that nature. So, but it doesn't matter which one you use in this case for the cosine of 2a. The one I'm going to use, let's just use the first one. So I'm going to say 1 minus 2 times, and then it's going to be the sine squared a. Well, a is negative 3/5. It's going to be squared. It's going to be 9 over 25. So now I have 1 minus, this is going to give me 18 over 25. So if I have this as 25 over 25 minus 18 over 25, this is going to equal 7 over 25. And it will work for any form of cosine of 2a. To find the second one, cosine of a over 2, I got to put in the cosine of a over 2 formula. First thing I have to do is check my quadrant chart, and in this case, the cosine of a over 2 in quadrant 3 is negative, so I'm going to put a negative on the outside of this, and now I can put in this formula 1 plus, plus cosine of a, which is, well, I'll just put it in there. Let's put it in there. Cosine of a is negative, will be what, negative 4 over 5 all over 2. So this is going to end up equaling negative 1 minus 4 over 5 all over 2. So let's pay attention to the numerator first. So let me get some more room here. So I got equals negative. I'm going to have a common denominator of 5 over 5, which is 1 minus 4 over 5 all over 2. Here I'm going to have, this is going to give me 1/5, so I've got negative square root of 1 over 5 divided by 2. So now I can go, I'm just going to pay attention to the fraction here. I'm going to move it over here, so I'm going to say 1 over 5 and multiply it by 1 over 2, which then is going to give me a minus square root of 1 over 10. So I'm going to multiply both sides by square root of 10 here. So then this equals negative square root of 10 all over 10. Okay? And that is being able to use the double angle and half angle formulas. Hope this helps. Till next time.